Okay, for this lesson, we are going to be solving rational equations, and this is going to be part one of two parts of solving these rational equations. But anytime we're solving a rational equation, we're solving, so there's some sort of equal sign in this. So if you see all of these expressions, there's an equal sign in each of the problems that we're going to work through. But the big idea that we need to understand now is when we are solving equations with fractions, okay, because that's what a rational expression is, just a fraction with a variable somewhere in the denominator or numerator. We want to eliminate all denominators. So we are going to just essentially any denominator we want to eliminate. Okay. And because the denominator in some fraction means division, then in order to eliminate a denominator, which means to eliminate division, we need to multiply, because that's the opposite of division, and we're multiplying by that denominator of what we are dividing by. So if we look over here at example 1, so we're going to solve for this variable x in this expression right here, 1, 6. Now, in order to eliminate dividing by 6, this is 1 dividing by 6, we're going to multiply by 6. So I'm going to multiply by 6. But when you multiply by 6, you can't just take this term and eliminate 6 out of it. Each term needs to be multiplied by 6. So the x needs to be multiplied by 6, and the 2 needs to be multiplied by 6. So essentially we are taking and we are multiplying all terms by the denominator. Okay. Now, after we multiply this, let's simplify if we can. 6 in the numerator and 6 in the denominator eliminates. 6 cannot simplify with 5, so we leave that 6. But 6 can simplify with a 3 in the denominator. That can become 2 and over 1. So now our result, the first term, now is just 1. There's no 6 anymore. We've eliminated the denominator. This next term is 6 times x, so it's plus 6x, and then it's still divided by 5, and that is equal to 2 times 2, which is 4, and it's divided by 1. Now, we really don't need to put 1 there. We can just say 4, but for this purpose, we're just going to write 4, or just write 1 over that 4. Now, we still have a denominator of 5 for this second term. So again, we are going to multiply all terms by 5. So in order to eliminate this 5 as a denominator, I'm going to multiply the 1 by 5, I'm going to multiply the 6x by 5, and the 4 by 5. And now there is no simplifying here with the 5 and the 1, but we can simplify the 5 and the 5 in the numerator and denominator for the term in the middle, but 4 and 5, that doesn't eliminate. And so now we have 1 times 5, which is 5. That's equal to, all that's left over in the numerator is 6x, so plus 6x, and that is equal to 4 times 5. Now this time I'm not going to put 4 times 5 over 1. I'm just 4 times 5 is 20. 20 divided by 1 is 20. So equals 20. Then we're just going to solve this equation like we normally know how to. 5 plus 6x equals 20. Subtract 5, and you get 6x, which is equal to 20 minus 5 is 15. Divide by the 6. And over here, x is equal to 15/6. Now 15/6 reduces, or is divisible, both of them are divisible by 3. So if we reduce the fraction 15/6, we get 5 over 2. And that is your answer, x equal to 5 over 2. Now you could say 5 over 2, well that is a terminating decimal, 2.5. So either way you write it, it's 5 over 2 or 2.5. Those are equal, they're the same value for x. That is your answer that solves for this rational equation. Okay. Let's go over to the second example. Okay. Now, anytime you have a binomial in the numerator, just know that that is assumed to have parentheses. And let's now eliminate the first term, which is dividing by 3. So I'm going to multiply by 3 to eliminate that. But you can't multiply just that by 3, multiply each term by 3. And I've already simplified this, you can see, but over here, you can note that 4 is the same as 4 over 1. We don't really need to put it over 1, but if you need to. But anyways, 3 over 1, there's no simplification that can happen with that fraction, but there can be in this last term, 3 in the numerator and 3 in the denominator. So what we have left, the first term is x plus 2, and then it's really over 1. I don't need to put it over anything. Plus 4 times 3 is 12. 12 over 1 is still 12. Is equal to, and there is no 3 over here because we've eliminated the denominator, so it's just negative 5x. Now this x plus 2 doesn't really need the parentheses anymore because there's no multiplication outside of those parentheses. So really, if I just add the like terms, it's x plus 14 is equal to negative 5x. I'm going to move this 1x to the opposite side, so we're going to subtract x. And the result after that is 14 is equal to negative 6x. Then we're going to divide by the negative 6. And negative 14 over 6 is the answer. Again, this is a reducible fraction, 14 over 6. Both of them are they're even, so they're at least divisible by 2. So negative 7 over 3. Now 7 over 3, if we put that into our calculator, 7 divided by 3, you would get a decimal, and we don't want to leave it as a repeating decimal. So we'll leave it as a fraction. Now you could say this is negative 2 1/3. I'm okay with that, but I don't want you to round it to negative 2.33 or whatever. Do not do that. Just leave it as the exact fraction or a mixed number. So I want you guys to go and try this one. Okay? So you can right now pause the video and try this on your own and then look back and complete this. But I'm going to continue this right now. But you can pause it, go and complete this on your own, check your answer afterwards by just playing the video through. 5r, I'm going to eliminate 5r. Now this is in parentheses r minus 2, so multiplying that by 5r and multiplying this by 5r. Again, I started just eliminating the 5r and the 5r. Now in this next one, the 5r eliminates with the 5 and the r, but we still have r squared in the numerator, or in the denominator, so only one of those two r's eliminates, so really there is still an r left over. And the 5r and the 5r also eliminate. So what we have now is all left over in the numerator is just a 2. There's nothing else. The 5r eliminates, so all we still have is a plus r minus 2. But that r minus 2 is divided by still an r because only one of the two r's eliminated when we multiply by 5r. So this is r minus 2 all over r. Now if you want to keep that in parentheses, you can, is equal to, and the 5r and the 5r eliminated for the last term, so all that was left over is 4. We still haven't eliminated all the denominators. Okay? There is still an r in this denominator. So to eliminate that r, I'm going to multiply by r in every term. But the r in the middle term can eliminate, but there's no denominator for that r to eliminate in the other two terms. So we are just left with r times 2, which is 2r. We still have this plus r minus 2. And it's in parentheses there. I left it without parentheses because no longer does it need to bring parentheses now that there's no factor or no fraction underneath it. And 4 times r is equal to 4r. From here, we can just solve the equation normally. 2r plus r is 3r. And then we have the minus 2 is equal to 4r. And then I'm going to move the 3r to the right side and subtract 3r. And the result is negative 2 is equal to 4r minus 3r is just 1r. So r is equal to negative 2. Now you try it. Hopefully you got something close to that. Now you can always check your answer by just inputting this negative 2 back into every point of r, and it should make an equivalent expression. But negative 2 is your answer. You can go check it if you wish. We must factor the denominators if possible. So when we are eliminating denominators, we want to hope to have a denominator on the top and bottom. So we are going to factor these and then find those factors and multiply by the factors of the denominator. So if we break this down, and if you do the x factor over here, numbers that multiply to get 1 times -5 is -5, and the b value is -4. The two numbers that multiply to get -5 and add to be a -4 are a -5 and a +1. So the two factors that r squared minus 4r minus 5 break into is r minus 5 and r plus 1. Now this second term also has a GCF if we're trying to factor that. So that's 2 times r plus 1. And the last factor also has a GCF of 2, but this is r minus 5 left over. So I'm going to just assume that you understand that all of these denominators that I have eliminated break into these two, and you understand that. We're going to now eliminate this denominator, r minus 5 and r plus 1. So we're going to multiply by two things. So I'm going to first multiply by r minus 5 and also multiply by an r plus 1. But we can't just do it to one term, we have to do it to every single term. So this is r minus 5 and r plus 1, and then r minus 5 and r plus 1. In multiplying by the r minus 5 and the r plus 1, the r minus 5s and the r plus 1s eliminate. If we go over here to the second term, only the r plus 1s can simplify. And then if we move over to the very last term, we have the r minus 5 and the r minus 5 eliminate. Now if I continue to move on, what's left over in this first term, we've eliminated the r minus 5 and the r plus 1, so there's nothing left over in the denominator. All that we have left is just 1 in the numerator. That's it. And that's equal to, we have 3 r minus 5, 3 times r minus 5, all over just 2, because 2 is the only thing left over in the numerator or the denominator, minus, this is 2 times r minus 1, or r plus 1, and that's all divided by the only thing left, which is 2 as well. So we've simplified after eliminating the first denominator. We still have this denominator of 2. Now they both have a denominator of 2. So we are going to multiply by 2 to each term again. And you can see that the 2 will eliminate in the second term, but also the 2 should eliminate in the third term as well. So now the simplified form is going to have 1 times 2, which is 2, and that is equal to just 3 times r minus 5 minus 2 times r plus 1. And now this minus I have attached with this negative 2. So when we go and distribute, the negative 2 is going to distribute into both of those terms. And I'm just going to simplify this just a little bit more by after the distribution. 3 times r is 3r. 3 times negative 5 is negative 15. And then negative 2 times r is minus 2r, but the negative 2 times 1 is negative 2. We are now going to solve this by adding like terms and getting the r value isolated. So the 2 doesn't change, but the 3r and the negative 2r just makes r. And then the negative 15 and the 2 is a negative 17. Pencil's kind of bleeding there a little bit. And then now to solve for r, we're just going to add 17 to both the left and the right side. And you get 17 plus 2, 19 is equal to your r value. And you can again go substitute r equals 19 back into any of these, and you should get a correct equation. These should all equal to each other, but r equals 19, your correct answer. The last one I want you guys to try on your own, so you can, again, pause this one more time and then unpause it after you've done it, see how far you've gotten, how close you got. Hopefully you get to the correct answer. If not, you understand what's going on. So I'm going to complete this, pause it now, check later. Now, we always try and factor if we can. So we know the denominator goes to x minus 5. This is the difference of squares, and x plus 5. Okay, we can factor that. The denominator 4x minus 20 has a GCF of 4. So this breaks into 4, and then what's left over is an x minus 5. And then the last denominator is also a difference of squares, x minus 5, x plus 5. So we've factored all of the denominators. Now let's eliminate this first denominator of x minus 5 and x plus 5. So I'm going to multiply every term by x minus 5 and an x plus 5. X minus 5 and an x plus 5. An x minus 5 and an x plus 5. Now let's simplify. So the x minus 5 and the x plus 5 in the first term eliminate, which is what we tried to do. But the only thing in the second term that eliminates is the x minus 5. With the x plus 5 is still left over. And then over here, the x minus 5 and the x minus 5 eliminate. So what we have left just in this first term is just a 2. So 2, no denominator. We've eliminated all denominators. Is equal to 5 is left over with also an x plus 5. So 5 and an x plus 5. But in the denominator, we only were able to simplify the x minus 5. We still have a 4 left over, so all divided by 4. Minus this 1 is left over with an x plus 5. Now you can put the 1 there, and I'm going to keep it just because this negative 1 is really right here, and that negative 1 is going to distribute into the x and the 5. So this is negative 1 and x plus 5. You don't need that negative, but you have to understand that that negative distributes into the x and the plus 5. But it's also, oh, I goofed. That eliminates 2. I didn't even see that. So really, this expression is just minus 1. Even nicer. That's even better, okay? Because now we only have to eliminate one more denominator, which is just 4. So I'm going to do that. I'm going to eliminate this denominator 4. And to eliminate 4, we're going to multiply by 4 to each term. That eliminates this 4. And so now what we have is 4 times 2, which is 8. And that is equal to, all that's left over is 5, x plus 5 minus 1. Now that's 5 is going to distribute into both of those terms. So you have 8 is equal to 5x plus 25. This should equal 1 times 4, which is negative 4, minus 4. And the last step is to solve for x. 25 and 4. 25 minus 4 is 21. So 8 is equal to 5x plus 21. Subtract 21, subtract 21. And that gets you a negative 13 is equal to 5x. Once you divide by 5, x should equal a negative 13/5. Okay. Now that is equal to also a negative 2 3/5, or that's also equal to negative 2.6. Either of these are all equivalent to negative 13/5.